Let me just let me upload the presentation and then we can continue. One more thing, I am going to paste the link for the Dropbox folder from where you can access material which we'll be using in this this workshop. So you can visit this link to download the material which we are going to discuss in 3 sessions. Okay, so this is the plan as you can see on your screen for the 3 sessions. Today, what we are going to talk about, we are going to talk about a brief intro about the SPSS software, the measurement part, because we are talking about quantitative data analysis. So the quantitative data comes in the form of numbers. So there are different level of measurements in quantitative data, which we are going to talk about, and then we are going to talk about different type of variables, because those of you who are going to take advanced data who are going to use advanced data analysis techniques in SPSS or other softwares like M+, MOS. You need to identify different type of variables, only then you can use those. So we'll briefly talk about the type of variables, and then we will see how we can prepare data in SPSS and how we can clean data, because that's the first step. If you do not prepare data well, if you do not clean data, then sometimes even if you run the analysis, you are going, it's going to end up in having biased conclusions or biased findings. So just give me. Okay, sorry. So, and tomorrow we are going to discuss the assumptions of quantitative data analysis and how you can check those assumptions in SPSS. And then we are going to talk about the descriptive statistics part, like how to do those in SPSS, like skewness, kurtosis, mean, standard deviation, normality, and also the bivariate descriptive statistics like correlation. And then the third day, we are going to talk about the hypothesis testing part. And there we are going to talk about like 3 or 4 techniques like t-test, ANOVA, and regression analysis. As you can see on this slide, the resource which I've mentioned, discovering statistics using IBM SPSS by Andy Field. This book is very easy to read, and it is written in a very layman's language. Even if you do not have any background of statistics, you will not find any trouble in understanding the contents of the book. So for those of you who are interested in using SPSS, for their research, probably that's, I would say, that's one of the best resources which you can use. I have placed a PDF version of the book in the same folder, the link which I've already shared, so you can copy it from the same course material folder. Okay, moving on. Now, this is how typically a quantitative research process is done. Now, for example, we choose, we start with a research question. We go back to the theory and literature and we generate hypotheses. And then in order to, and those hypotheses, those involve variables. That's why it's important to talk about the variables. So once you have those hypotheses with you, and hypotheses are basically testable statements, which you can test. So in order to test those hypotheses, you would collect data or you would design a study, I would say. So collection data is a very, I would say, it's too simple term, but it involves talking about or thinking about the design part as well. So you would design your study, and after thinking about the design, you would collect data. And once you have the data with you, you will put it into a software. Like nowadays, people are using Spss, MOS, M+. These are the softwares predominantly used in social sciences. So you will use, like you will put these into a software. You prepare data according to the requirement of that software which you are going to use. And then based on based on the type of hypothesis you have, you would test it by using appropriate statistical technique in that particular software. And the idea is you will fit a statistical model to the data. That statistical model might be ANOVA, t-test. So basically statistical model here is the tool or the technique which you are going to use. And then you would interpret output from that model to see that whether your data supports your hypothesis or not. So this is how typically the quantitative research is conducted. So now you can see that why we need these data collection, data analysis tools, because once you have the data with you after step number 3, you need to have some understanding that how that data analysis would be done. Only then you can test the hypothesis. Okay. Now, as I mentioned, that hypothesis, these are testable statements, and these statements involve some variables. Now, how do we define variables? Variable is something which is not constant, which changes in the population. Now, for example, can anyone give me an example of a variable? Easy question.
Age.
Yes, very good. Age is a variable because if you see age in the population, that changes. What else? Okay, yeah, weight, temperature, BMI, excellent. So these all are the variables. What might be the constants, or what might be the things which are not variable? For instance, speed of light.
Gender.
No, gender is also a variable because you have 2 possibilities or 3 possibilities in gender. You have male, female, transgender. So you can have 3 values, and in the population, these 3 values, change when you move from one sample to another sample. So gender is also a variable. Like speed of light, that is not a variable. Pi is not a variable. All other, constants which you come across where the value does not change, those are not the variables. Okay, so now you understand what do you mean by variable? Anything which changes in your population or in your sample. Now,
may I just ask if my assumption is right or not? If my study fixed, for example, the gender, then the gender, for example, if I need to conduct my study on male adults, then the age and the gender is constant here in this study design. Am I right? Or
yes, if you are conducting only your study on male, then male is not a variable. And age, if you are conducting on your study only of those who are 18 years old, then age is also a constant. Correct. Okay. Okay. So now you may have, depending on that how you frame your hypothesis, you may have different type, or we use like different types of variables in your hypothesis while you build your hypothesis. Now, predominantly, we always have independent and dependent variables. Now, independent variables are those which are, now, for example, which lead to something. Those are independent, which means like we are not, factors impacting something. Your dependent or outcome variables are those variables which you are interested in knowing that what impact these variables. And similarly, you also, the other two types which appear in advanced analysis, you might, when you read these statistical books, you might come across these terms are mediators, moderators, and control variables. Mediator variables are those variables which serve as an underlying mechanism or intervening mechanism between independent and dependent variable. And moderator variables are those variables which change the strength of the relationship between dependent and independent variable, which means, for example, as you were saying that, just take the example of a gender. If you are talking, okay, we will see the examples. And control variables are those variables which we only control in our analysis. Now, typically, most of the time we control for demographics. For example, we control for age, gender, qualification, nationalities, years of working in a specific organization. So these all are the variables which most of the time we serve as a control variables in our analysis. Now, for example, if you look at these, some of these examples which I have here put down on the slide, if you look here, the first is blood pressure is negatively associated with heart health. Now, anyone who can identify the variables in this hypothesis and what are their types?
Hello, can I?
Yeah, please.
All right. The blood pressure is negatively associated with heart health. So blood pressure, I believe, is the dependent variable. So it may be high or low.
Mm-hmm.
And the heart health most probably would be the independent variable. This is what I think.
Okay. Anyone else? Okay. Now, to some extent, you are right in a sense that when we talk about the association, we are not interested, or for example, we cannot tell with certainty that which variable is dependent and which is independent, because we are only talking about association. Association means a relationship, but we are not saying that A is causing B. Now, when we say blood pressure is causing heart health, now in this case, blood pressure is an independent and heart health is dependent variable. Or if we say heart health is causing blood pressure, now in that case, heart health is an independent and blood pressure is dependent. But the way
very clear. Yeah.
But the way this statement is written, that they are negatively associated, here we are not talking about causality. Now, when I use this word causality, that means that which factor is causing which one. is the blood pressure causing heart health or heart health is causing the blood pressure? We are not clear because this is not, this is not evident from this statement which is written here. It only talk about the association. And when we talk about the association or relationship, we are not sure that which is dependent and which is independent variable. But at the same time, we can see that there are two variables in this, which is blood pressure, because in your population, blood pressure varies, and the heart health, which is also a variable in your population, the heart health also varies. Now, if we are interested in causality, we would say that blood pressure leads to, now when you're using these terms like blood pressure leads to good heart health, or there is a positive, now here, like for example, we are talking about causality, that blood pressure leads to good heart health. Now, when you say leads to, it is clear that blood pressure is independent and heart health is dependent. Now talking about the second statement, BMI is positively associated with obesity level. Can anyone tell me that which, do we see some in this statement?
If you allow me, just
Yes,
before we
please,
go to
go
the
ahead.
second statement, just wanted to know what is the role of the adjective negatively in the first statement. So, what is the role of this adjective?
Negatively, okay.
Doesn't that mean the blood pressure will affect the heart health negatively, or this is something else?
No, negatively associated means that if one of the variable goes up, the other will go down.
Okay, I got it.
Variable go down, the other will go up. This is a negative relationship or negative association. If both in the same direction. Now, for example, in the second statement, we are saying positively associated. Now, this means that if BMI goes up, the obesity level will go up as, and if BMI goes down, the obesity level will go down. So which means like both variables move in the same direction. If one goes up, the other will go up. If one goes down, the other will go down. Now that is what is positive association. And the negative association, or which we call the inverse association, is if one of the variable goes up, the other will go down. Okay, clear? Okay, now talking about the third statement, which says psychological well-being mediates the relationship between workplace happiness and workplace performance. Now, anyone who can identify the name of the variables and their types in this statement, the third statement? Anyone who would like to take a chance?
Yeah, I can do that.
Yeah, please.
So we have the major relationship between independent variable workplace happiness and dependent variable workplace performance. And then we have the mediator of this relationship as a psychological well-being.
Excellent, excellent.
And I have a comment to your previous statement, just to clarify. Is it from the statistical point, the positive association, or we also can interpret it? For example, BMI, if we increase BMI, and then we have positive association with obesity level. So in that case, obesity level won't go down. I think it will go down, right? Because it will kind of decrease. No?
No, this is just a general statement. We are not
all right.
talking in real sense. It's just for illustration purpose. When we say
Okay.
it means if one thing goes up, the other will also go up. If one goes down, yeah.
Okay.
But in real sense, you are right. You know, if we have to test this hypothesis in reality, probably this is not going to be spotted because we are probably going to find a negative relationship, right?
Yes, exactly. All right. Thank you.
Yeah. Okay. So thank you, Izan. Now you can see the third statement. We have independent and dependent, like where we have like workplace happiness leading to workplace performance. And this relationship, now what is the intervening mechanism? Like what happens between these two is the psychological well-being, which means like workplace happiness that leads to psychological well-being, and psychological well-being reflects in the form of workplace performance. Now, this is how we, up there, I mentioned the mediator. Now here you can see, this is how typically a mediation hypothesis is written, that X mediates the relationship between Y and Z. So here psychological well-being mediates the relationship. When we say that mediates the relationship, that's a kind of underlying or an intervening mechanism which your independent and a dependent variable. Now, talking about the last statement, the relationship between workplace happiness and workplace performance is stronger for females as compared to males. Now, anyone who can decode it in the form of variables and their types? Anyone from the class?
Well, the independent variables are is the gender.
Independent.
And yeah.
Okay.
And the dependent variable is the strength of the relationship between workplace happiness and workplace performance.
Mm-hmm. Anyone else who would like to agree or disagree? Yes,
Yeah,
sir.
yeah, I can comment on it. So basically, when we have relationship, the word itself, the relationship between two things, so those two things are our variables. So, and definitely the first one is always the independent, the factor, and we have here workplace happiness again. So workplace is independent, and the work performance itself is the dependent variable. And then we have stronger for female. This is just a cross tabbing. We have different groups, right? So, and the same relationship is stronger for just females. And it's the statistical number for males would be lower, right? Less stronger significant.
Now, okay, you identified correctly the dependent and independent, but what about males and females? If we just have to label them as a variable, what label would you use?
Oh, you mean like in terms of variables?
Yes,
Control
yes.
variables.
No, they're variables, but what type? If we have to pick one of the four, which I mentioned up there, one of the fives, like dependent, mediator, moderator, control, which one you would go for?
Yeah, I said control variable.
Control, okay.
Yeah. Okay, you think it's moderator?
Yes.
Okay.
Moderator, because as I mentioned that moderators serve as a boundary condition on your base relationship. Now here, if I have to decode this in the form of variable, I can clearly say that workplace happiness is an independent variable, workplace performance is a dependent variable, as mentioned by Azan. And then there's a boundary condition, or there's a moderating effect of gender on this, which means now male and female are the two categories of a variable which we can use as gender. So, which means that the relationship between workplace happiness and this workplace performance, that is not constant across different genders. The relationship that varies when we move across different categories of the gender, which means this relationship is more stronger for females, like they drive more, like they are a better performer, which they are driving from their workplace happiness as compared to females. So this variable gender, which has two categories, male versus female, that serve as a moderator or as a boundary condition on our base relationship, which is always between dependent and independent variable. Okay, clear?
Well, my question here, how do you recognize which one is dependent and which one is independent, as long as it says relationship? So it is something that only like the association. Is it right?
Yes, you are right. You are right. But now the idea is like, because when you build your hypothesis, your arguments tell you that in which direction they are pointing, because based on your arguments, you write the hypothesis, and based on the hypothesis, you draw a pictorial representation of your model, which we call like theoretical model or proposed model with hypothesized model. Now that model is connected with the help of arrows. Now that arrows tell you that which one is dependent and which one is independent. So basically my idea is your theoretical arguments would tell you that which one is leading to which. So which is independent and which is dependent. Now I can quickly show you one theoretical model, for example, one of my studies, which probably you can see and see that how we can represent and how, like for instance, these look like. Just give me a second. I'm going to one file here. Okay, for instance, this is, can you see this Word file?
Yes, we can.
I do. Yes, I do.
Okay, so for instance, if you go down, you like, this is how typically we write paper in social sciences. For example, you have theory and hypothesis development. So you are using a theory to write the hypothesis. And here, for example, this is a hypothesis, hypothesis 1. A supervisor's Machiavellianism is positively associated with her supervisor's perception of abusive supervision. And then you have a mediation, and then you have arguments for the mediation, and then you write this hypothesis 2. A supervisor's competitive worldview mediates the link between Machiavellianism and her blah. And then you have another variable, which is moderating role of subordinates performance. And then you have the arguments, and based on the arguments, you made your hypothesis, which is like the subordinates perception moderates the indirect effect of blah, 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 blah. And, then at the end, what we do, we present these hypotheses in the form of hypothesized model. Now, can you see this model?
Yes, I do.
So now if you look at this model, you can see that which one is the independent variable?
The first from the right.
Yeah, the first one, which is supervisor's Machiavellianism, right?
Yes.
And which one is your independent variable?
No, you mean dependent.
Sorry, dependent. Sorry. Which one is your dependent variable?
Abusive supervision perceptions.
Okay, perceptions of abusive supervision. And which one is a mediator?
The competitive worldview.
Which one is a mediator here?
The competitive worldview.
Mediators serve as an intervening mechanism between your dependent and independent, right?
Yeah, I think
So can you see an intervening variable here between your dependent and independent?
Yeah, Hussein just responded. It's the supervisor's competitive worldview.
Yeah, so supervisor's competitive worldview, that's a mediator between Machiavellianism and abusive supervision. And which one is moderator in this model?
The subordinates performance evaluation.
Yes, subordinate performance. So basically, if you look at this last leg, so basically we are saying that the relationship between competitive worldview and abusive supervision, that is not constant. There is another variable which is impacting this relationship, and that variable which like play a role on the relationship itself, that is our moderator. Basically, we are saying that this relationship is not constant between worldview and abusive supervision, is not constant under each and every circumstances. Rather, it depends on subordinate performance. So maybe those subordinates who are performing high, they would get less abuse. So the relationship is weaker, and those subordinates, the other group which are low performer, for them, the relationship is stronger. So this is how, like, for example, this pictures clearly tells you that which is independent, which is dependent, and which is moderator and mediator. And again, from where this picture is coming from, this is coming from your theoretical arguments. Because again, the process is that you choose a research question, you go back to the theory, you use the theoretical. If theory is saying that this leads to this, alas, you clearly know that which one is dependent and which one is independent. So based on those arguments, you write down your hypothesis, theoretical arguments, and then you present them in this form. And then at the next level, you test those. Okay?
Yeah, thank you. This is more clear now. Thank you very much.
Okay, okay. I'm going back to my presentation again. Okay, so the next thing is a level of measurement. First, we are going to talk about the categorical. So there are two levels of measurements. The first one is the categorical, the second one is the continuous. Now, categorical measurement means where you have different category in your variable. So categorical measurement can be further classified into three types. The first one is the binary variable. Now, the binary variables are those variables, as the name suggests, where you only have two categories. For example, dead or alive, absent or present. So this is a binary variable. Then another type in categorical is nominal variable. Now, when you have more than two categories in your variable, now that's a nominal variable. Now, for example, whether someone is an omnivore, vegetarian, vegan, or fruitarian, now that is a nominal variable. You have more than two categories. And the third one is ordinal variable. Now, ordinal variable is also a nominal variable, like you have more than two categories, but there's a logical order in those categories. For example, your grading system, A minus, B plus, B minus. Now that's an ordinal variable because we can order these categories according to a logical order. For instance, qualification, high school, undergrad, master's, PhD. So we can again order. So that's an ordinal variable. Okay. The second type of measurement is continuous measurement. Now the continuous is like where you don't have any categories. For example, height, blood. Yes.
For example, if we have a variable which is the age in years, how do you categorize it? Is it ordinal or it is continuous?
Okay.
The age in years without having fractions in it.
Yes. You know, if you are only capturing age in years, that's a continuous variable because it's like you can have any value possible from 1 to maybe 90. So but if you categorize it like this, for example, let me show you one of my survey, and then you will get a better idea. For example, if you look at this survey, you have certain questions, right? And then you have a Likert scale from strongly agree to from strongly disagree to strongly agree. What type of measurement this is? We call it a continuous, measurement. Although it can be, you can categorize it into 5 categories, but again, it depends that how you treat this. And in 99% of the cases, all the Likert scales are treated as a continuous measurement scale in your research. Sometimes you have a 7-point Likert scale, sometimes 10 points. Now this is a continuous measurement. Now if you go down, here we are capturing some demographics. Now, what about the gender? What type of measurement is this? You see here, gender, male, female.
This is binary.
Yes, this is binary, only 2 categories. Now, what about here? Age.
This is categorical.
This is categorical, and even like you can call it ordinal, because this you can arrange them in a logical order. But if I have asked the respondent that what is your age, now do you think that can still be a categorical variable, and just employees just have to mention that what age they belong to? For example, if I, instead of having these categories within the age, I ask the employees that what is your age?
No, it will be continuous, the number.
Yes, exactly. Then it would be continuous, because now I can have any value starting from maybe 20 years till 70, 80 years. So I don't have any discrete categories. But if I code the age like this, the way I'm capturing it, now that's a categorical variable. Similarly here, this is also a categorical variable. Experience with the current organizations, I made like 4 categories, but if I've asked employees that how many years of experience you have with your current employer, now then it had become a categorical variable. So it depends the way you have captured that information. If it has been captured in the form like you have initially conceptualized it at a different categories, then it's a categorical. But if you have asked a question like where it can come up with any value and where you do not have any discrete categories in your head, now then it becomes a continuous variable. Is that clear?
Yes, it's clear. Thank you.
Okay. So again, I'm going back to my presentation. Okay, so we're talking about the level of measurements. Okay. So, yeah. Okay, now, so this was some of the basic stuff which I thought you should be familiar with before we move on to the software part. So now I'm going to upload, I'm going to open the blank SPSS interface. Now SPSS stands for Statistical Package for Social Sciences. And you will see that there are 2 views in SPSS. One is the variable view and the other one is the data view. And then we will see that how you can create data or import data or copy data from Excel into SPSS. So this is what we are just going to do, these 2-3 things. We are going to get ourselves familiar with the interface, and then we are going to talk about that, how you can name variables, how this variable view and data view look like, and how these are different from each other. So I'm just going to share screen of the SPSS, and I'm going to stop sharing this PowerPoint presentation. Okay, here we go. And okay, whenever you open SPSS, you will come across a window like this. Now, this is the blank SPSS interface. Now, this is here, if you can see down here, this is data view. And if you click here on the other button, it will tell you the variable view. Now, as the name suggests, in variable view, you can have a configuration of the variables which you are going to have in your data set. So this is basically a control panel type of window where you can change the names of your variables, where you can change the type, where you can put in the labels, if there are any values and things like that. And here in the data view, you have the values on those variables. Now, this is a blank window. For example, I'm just going to talk about the variable view first. For example, I am interested in analyzing the relationship between the number of hours the graduate students study per day and their grades, their grade in that specific course at the end of the semester. So now I'm interested in knowing analyzing the relationship between number of hours of study per day and the grade in that particular course. So how many variables I have here in my research problem?
2.
2. Excellent. Which are those 2 variables?
The number of hours and the grade they may have.
Okay, number of hours and the grades. And I can also give another variable, serial number, okay, to my cases. So basically, serial numbers serve as a primary key for all cases. So I would like to have a serial number as well. So from that sense, I have 3 variables. First one is serial number. So here I would type the name. I can just type serial, just code number. Okay, that is the first variable name. What should be its type? If I click on the type, you can see this new window, which has like numeric, comma, dot, date, dollar. So I would just choose numeric. Okay. So numeric. Width by default is 8. Now width is like how many characters we can have here, but you can change it to 8 to anything like 9, 10, 11, 12. It's up to you. Decimal points 2, and if you want to move it to 0, we can do that. Label. Label is now here name. Basically, if you look here, name is a short name which would appear in your Spss analysis. And label is, for example, if I just showed you the question and we had some statements. So variable name, I cannot have the whole statement because Spss only would allow me to have a name which can't be more than 8 characters. So I would have a short name for this, and then in the label, I would put the whole statement. For example, here I can write serial number, okay? And if I move on, we have the values. Now values is, for example, this is for those variables which are categorical. In categorical, if you have values for 1, 2, 3, 4, for example, the age brackets. So here you need to declare that what is meant by 1, what is 2, and what is 3. For example, if I click here, I can give the value and the label and I can add it and it would come here. This I'll show you later, okay? Missing, you just leave it like this. If you click here, now no missing values, okay? And column and blah, and then you come here on the measure. Now, if you click on the measure, you would have the same types what we just talked about. You have a scale. Scale is like a continuous. You have an ordinal and you have nominal. So I would just select here scale because serial number can be from 1, 2, 3, 4, 5, 7, 8, 9, 10, 12, 100, 200, 500, anything. Scale. Okay. So this is how I configured my first variable, and this one you just leave it like this. Role, don't change this role. Okay. So this is my second variable was hours per day. Okay. I can make it hours per day, and okay, decimal I can give 0. This is number of hours of study per day. Okay. And then similarly in here I can give scale because it's a continuous variable. The third one is grade. Okay, so grade is, for instance, grade at the end of rated at the end of the semester. You can, and here I can again make it a scale. Now, for example, in grade, yeah, just take the example of grade. We have like A, B, C, D, and so on. So here, what I can do, I can go to values. I can here define if the grade is 5, value is 5, the grade is A. Okay, value is 4. We can say the grade B, value is 3, grade C. Okay, so for example, I put, can you see this small window or no?
Yes, we can see it.
Okay, that's great. So 5 is A, 4 is B, 3 is C, 2 is, for instance, D, and 1 is F. So basically what happened, I had grades in the form of alphanumeric characters, or which were not in the form of numbers, but the SPSS only understands the language of numbers. So what I have to do, I have to convert these grades in the form of numbers, or I have to code these grades in the form of numbers so that SPSS is able to understand this, and we are able to find a relationship between them. Okay, here I put okay, and this is scalar. Now I have configured all the variables name related to my research problem or hypothesis. And now once I click here on the data view, I can see that these 3 variables name appear here: serial number, hours per day, and grade. For example, I can just put in some hypothetical data: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, hours per day, for example, we have 4 hours, 5 hours, 6 hours, 3 hours, 2 hours, 4 hours, 5 hours, 6, 8, 9, 9, 9, 10, 11, 4. Okay, so these are maybe when, for example, the questionnaires on which I get collected data from students, these are the values which are found on questionnaire survey 1, survey 2, and so on. And the grades we have for example, here we can put, let me go back to see that. Okay, so data, I have values. I can here go back to the variable view and see that what values I have. I have values from 1 to 5. So here I go to data view. 1, 2, 3, 4, 5, 5, 5. 2, 2, 3, 4, 5, 6. Oh, sorry, we don't have 6. 5, 2, 1. So these are, grades. Now, for example, you can see a button here, which is, can you see this button, value labels? So if I'm interested in knowing that which value is corresponding to which grade, or here I just want to have these grades in itself, I can just click on this button here. It's the value button, and it will show me the grades. But if I click again, it will be in the form of numbers. Now, this is, okay, when I click here on the save, this asks me for allocation to save. I'm just going to save it in the same folder, for which I've shared the link with you. Okay. Class practice. Okay. So if I have to see the relationship between grades and hours, number of hours studied per day, what I can do, I can here click on analyze. Now, let me tell you one more thing. All statistical, 90% of the tests, statistical tests, which you use in SPSS fall under this analyze button. You can see all of them are here. Now, because I am interested in the relationship at this point in time, I just want to see that what is the nature of relationship between numbers of hours numbers of hours of study per day and the grade. So I click on analyze. I go to here descriptive statistics. Now, one way of doing this in descriptive statistics, you have all these things. Now, these things typically we used for data cleaning and data preparation, but I'm not going to doing it. We will do it in like tomorrow and tomorrow. But here, if you are interested in knowing just the correlation, just go down, go to here correlate, and correlate. You click on bivariate. Bivariate means the correlation between means two variables. So if I click on the bivariate, this would show me this window where I have all these variables which are in my data set listed here. Okay, so now I am interested in knowing the relationship between number of hours of study and grades at the end of the semester. I'll just drag them from this window to this variables window. Now I'm going to select Pearson correlation, because whenever your variables are scale or continuous, we would always select Pearson. Pearson is the default tick you would find here. And then from here the default setting is two-tiered. We would just keep it like this. Flag significant correlation, we would just check it. Flag means it will put stars on that. Now, for example, if you go to options, it also tells you that do you want means and standard deviation of these variables. If you're interested in looking at the means and standard deviations as well, you can just check it. And this is for the missing values. If there are any missing, SPSS would exclude those cases pairwise. Pairwise means that if you have a missing value on any one of these pairs, pair means like two variables which we are interested in, SPSS would exclude that case. Okay, so we would just keep it like this. You here click on the continuous, and then you click here on OK. Now, once you click on the OK, it would open into a new window. So can you see this new output window or no?
No.
Okay, so let me stop share the data and share this output window. Yeah. So once you click at the OK, now this is the window which the result will open in a new window. Now, can you see that?
Yes.
Yes.
Okay. Now, for example, let me just open. Yeah. So you have here descriptive statistics, because we asked the SPSS to give us mean and standard deviation. So it is giving us the mean and the standard deviation. So number of hours of study per day, the mean value is 5.94. And grade at the end of the semester, the mean value is 3.38. Standard deviation. Are you familiar with the concept of mean and standard deviation? Anyone who doesn't know what is meant by mean and standard deviation?
I am not actually.
Okay. No worries, because this course is for beginners and we have to start from the zero. So you are feel free to ask, because sometimes I'm assuming that you already know this thing, but if you do not know, please feel free to ask. Now, mean is basically the average value. For example, if you have 10 observations, what would be the average value? How you would get the mean? You would add all those 10 values and you would divide it by 10. And you would get the mean or the average value. Sarah, clear?
Yes, doctor. Yes. Thank you.
Okay. And standard deviation is basically the spread of those values. So the bigger value of standard deviation means that we have a bigger spread in our observations. The smaller value of the standard deviation means that we have a small spread. Now, for example, if you look at the mean value of number of hours of study per day, the mean value is 5.94. Now, if majority of the class or majority of my sample size, whose values are 6 and 5, 6 and 5, 6 and 5, and the mean value is 5.94, which means the highest value is 6 and the lowest value is 5 from my, the observations which I received. What do you think? Does this data set has a bigger standard deviation or smaller standard dev? Anyone? My question is the 16, the n, n here means the number of observations. For example, just consider this scenario. Out of these 16 values, the lowest value we have is 5 and the highest value we have is 6 or 7, 5 and 7. So what do you think? How the standard deviation in this case would look like in our data set? Whether our data set have a bigger standard deviation or smaller standard deviation?
I think it will be small because the difference between 5 and 6 is just 1. So I don't know.
Perfectly right. Because the spread is very small. Spread is from 5 to 6. All the values lie between 5 and 6. So the spread is very small. So that's why you are going to see a smaller standard deviation. I'm not going to, in the background statistics that how standard dev is calculated, but this is just a layman's concept that the spread of your observations, that is standard deviation tells us the spread. And as a quantitative researcher, are we interested in a bigger spread or smaller spread?
Smaller.
Sorry?
Smaller spread means that the data is homogeneous.
Okay, smaller spread. Hussein is saying smaller spread. Anyone else? Look, statistics. Okay, let me ask this question here. Are you interested in a bigger spread or smaller spread in your dependent variable? Now, as far as your, yes, anyone?
Yeah, I don't know. I think that if the spread is bigger, then you've got more different cases. For example, let's say, I don't know, like if a person has a lower grade and a person has got a higher grade, and there is more difference among the individual. I don't know, like from a humanistic point of view, but I'm not sure if it's correlated. I mean, if it makes sense, or if it
Okay. Okay, good. Anyone else? Okay. Now, basically what happens, all statistical models, they try to explain the spread in your dependent variables. Now, for example, if the grades of all, for example, here, our dependent variable is grade at the end of the semester and independent variable is number of hours of study per day. If all students got the same grade, A, which means the standard dev, we would have what would be the standard dev if all the students 16 out of 16, our sample size here in this case, they got A grade, what would be the standard dev in this case?
0.
Zero.
Exactly. If standard dev is 0, which means we have 0 variation, and which means it is no longer a variable, it is a constant now, isn't it?
Well, we cannot say that unless we can generalize it over the population.
No, because the idea is here you're not having, the idea of statistics is that you get a sample size, you test that phenomenon in a sample, and then you assume that this is generalizable to the population, okay? Now, and this is the first assumption, that's why we go with the sample, we don't go with the whole population, because we assume that we have chosen this sample through randomness, and whatever results which are coming from this sample, that is generalizable to the whole population. This is how statistics work. Now, if the values of grades, if everyone is getting A grade, which means we have a 0 spread, 0 standard dev. If a standard dev is 0, which means that is no longer a variable, that is a constant, because everyone is A. And if there is no spread, statistics would fail. So you have no factors which are going to explain that spread because there is no spread. You got the answer. So ideally, we should have spread in our dependent variables. Only then we can explain that spread. So statistics is only concerned in explaining that variation in the values of your dependent variable. And if there is no variation, no statistics, which means that is no longer a variable. So coming back to the question which I asked initially, that would you like to see a bigger spread or smaller spread? If you ask me this question, I would say that I would like to see a spread or a variation or a variance. So I've been using these terms interchangeably, but these in my dependent variables, only then I'm able to explain that with the help of statistics.
Sir, excuse me, how I
Yeah.
know that I have high standard deviation? What is the number of high standard deviation?
You know, there is no cutoff point. Most of the time, we go back to the previous studies and see that what is the average standard deviation which people have been, because sometimes if you get an abnormal standard deviation, a big spread, that is also problematic if you're not able to justify it. Because if it is, because, you know, we always expect that the population or, you know, the studies which have been done elsewhere, the population, they more or less have the same characteristics. And that's why we don't see very big, you know, deviations from those numbers when we run those studies in a different context. So coming back to your question is, you should not have a spread of 0. I think anything above 2, that is good. But again, you need to go back to the previous published studies, and you have to see that the researchers earlier who measured that particular variable, what is like the average spread look like? It is between 2 to 4. If that's 2 to 4, you are fine. But anything I think above 2, that's good.
Doctor, can you please just correct
Thank you,
my
sir.
assumption regarding this? Actually, the value of the standard deviation, whether it is large or small, depends on the value of the mean. For example,
Yes.
if the variable that I'm measuring and doing statistics about is measured in millions, for example, then my standard deviation is only 2. Then this is too small. Regardless, it is correct, it is something good or not, but it is too small. But if, for example, like the example we have here, our mean is 3.38, then the standard deviation is 1.5, which is almost 40% of the mean.
No,
It means
you know,
that it
look,
is very large
basically,
standard deviation.
yeah. Hussain, basically, the standard deviation is calculated in comparison to mean, relative to the mean, which means like this is a normalized value. Now, how you calculate the standard deviation? Basically, you see, look at the variance of the value from the mean. For example, if your mean value is 5 and your value which you're looking at is 6. So it would be 6 minus 1, like 1. You take a under root of that and then you divide it by the mean. And then you add all those values, like for every point. So in other words, even if like the mean is bigger, at the end you have to divide the whole variation divided by the mean. So this is a kind of normalized value. So I don't think so that the mean has a role to play in, because that is at the end, if a bigger mean, it is divided by the bigger value.
Isn't the standard deviation the average distances of the observations from their mean?
Average from the mean?
Average distances of all observations
Yeah,
from their mean.
Yes, average of that square root divided by mean, relative to the mean.
Mhm.
Yeah.
Clear.
Okay.
So if my mean is a 3.38, like the one that we have here, and my standard deviation is 1.44, it means that the average distance between the average distance of the observations from the mean is 1.544. But if my mean is 300, for example, then my standard deviation is 1.544. Then it means that the average is too small. All the values are around the 300.
But you know this, like you will never like get a standard deviation like 300. The reason I'm saying is at the end you have to divide that average value with the mean. And even if the mean is bigger, again the standard dev would fall into this this range.
Okay, clear, Doctor. Thank you.
Okay. So, and here you can see that on the next point, n in the third column, n means the number of cases or your sample size. Now, if you go down in the next table, we have the correlation table. Now, what is the correlation between a number of hours of study per day and grade at the end of the semester? So the correlation is minus 0.05. What does this mean? Is this a strong correlation or weak? Okay, let me tell you one more thing. The correlation values vary between -1 and 1, which means the maximum value you can have of a correlation is 1 and the minimum value is -1. Now, minus sign indicates that if one thing goes up, the other thing will go down, which probably is not the case here because this is fictitious data. Otherwise, if we could have expected, like if like number of hours of study per day is going up, the grade should also go up. But the second thing is we do not interpret these values. We look at the significance level. Now, if you look here, the significance here is 0.838. This significance is also known as the p-value. Now, what is a p-value? Or what is the significance value in statistics? Anyone who can tell us? If you look here, the significance two-tailed, that is 0.838. Now, just a rule of thumb from a layman's perspective, this significance value should be less than 0.05 in order for us to interpret the statistical coefficient which we are looking at. Now here, the statistical coefficient which we are looking at is Pearson correlation, which means the relationship coefficient between grades at the end of the semester and numbers of hours of study per day. Now in this case, we will not interpret this coefficient because the p-value or the significance value or the second column which says significance two-tailed, it is not less than 0.05. It is way higher than 0.05, 0.838. Now, what does this mean? If this p-value or significance value, I'm using these terms interchangeably, p-value, because in papers and statistical reports, you come across this word p-value. So this p-value is not less than 0.05, it is greater than 0.05. This means that this correlation coefficient is not significant between these two variables, which is number of hours of study per day and grades at the end of the semester. If this coefficient is not significant, it means we can safely say that there is no correlation or there is no relationship between numbers of hours of study per day and the grade at the end of the semester. This is what our data is telling us. Okay, clear?
Sorry, can you please, if you allow that, you rephrase the meaning of the significance value?
Okay, please go ahead.
Can you please rephrase it or repeat it? The meaning of
Okay, you're telling me. I thought you were saying that you
significance.
want to rephrase it. Okay. So basically, we will talk about this on the next slide, that p-value or significance value is the probability of how to say, let me put it in a more simple term. The probability that this value is going to true in the population. So for instance,
so if it is less than 0.05, it means that there is probability 95%. This is correct.
yes, exactly.
Okay, clear. So
Yeah.
here we have very low probability, which is almost 0.16.
Yes.
Okay, can I ask a question?
Yes,
Also?
please.
Sorry, and yeah, because I was about to ask the same to reiterate. So the Pearson correlation is minus 0.56, right? And the p-value is 800. So, and you said that if the p-value is bigger, there should be no correlation. What if it's the same as the Pearson correlation? And what if it's slightly, I mean, if it's slightly bigger, then there is no correlation. But I mean, like, yeah, how you gonna explain this, or how would it appear in writings, or what is the outcome of it? For example, if it's equal or if it's slightly bigger, then of course, like, there is a change in the research, I believe, or in a change in the correlation.
No, look, Sarah, whenever we run any statistical test, the statistical test gives us a statistical coefficient or a number. Now, in this case, we ran bivariate correlations. So the bivariate correlations are always represented with R. So here, the small r, like small r between a number of hours of study per day and grade at the end of semester is minus 0.05. Now, we only interpret that coefficient, or we only consider that statistical coefficient, whatever that coefficient is. That might be a regression coefficient, correlation, or any other, or a t-value. We only consider it if it is statistically significant. Now, statistically significance is determined by looking at the p-value. Now, in this case, the p-value is 0.83, or if I round it, it would be 0.84. Now, p-value has to be less than 0.05 if we claim that this specific statistical coefficient is significant. So which means if p-value is not, if p-value is not less than 0.05, we would not interpret that coefficient, because in statistical, that is not statistically significant. That is a by chance value. That is not something to look at. And
Okay, so it's black and white, basically. Thank you. I get
Yeah.
it.
yes, yes.
Okay.
Yeah, the first thing. And coming back to the question which Hussein asked, and I'm just repeating myself, that basically p-value is the probability of, of this statistical coefficient being true in the whole population. Now, in this case, if p-value is less than 0.05, we can say with 95% surety, or there is a probability of 95% probability that this value is going to hold in the population, or this value is going to true in the population. So that's why the cutoff point for a p-value or for a coefficient to be significant is we take like 95% confidence interval, which corresponds to 0.05 or 5% of p-value. Now, some times people also look at 99% confidence interval. Now, in that case, your p-value should be less than 0.01, not 0.05, because now you want to be 99% sure, or there's a 99% probability that this value is going to be true in the population as well. Okay? We'll talk more about this, don't worry. Okay. So this is how, like, for example, this was just a brief intro that how you play with the SPSS and how you do this. Now, again, let me just stop sharing it and going back to SPSS data file. Okay, so this was our data file. Now, so this is one of the ways through which you can input data into SPSS. Now, for instance, I just want to remove all these variables. Okay, I selected this, I put shift, this, I just press del key on my laptop and everything is gone. Here, the data is gone. Now, the second way to, for example, you collected data on SurveyMonkey and now you have the data set with you in the form of an Excel file. Now you can, import that data from Excel to SPSS. So how you can do that? You will just click here. You will click here on the file. You will click here on the import data, and you will go down here to Excel. Okay, if data is in the form of a CSV, you will click CSV. But for example, my data is in Excel. I will click here Excel. Now, it's I will select the folder where my data is. Okay, there's no data in this folder, so okay, so I this is data like journal.csv. So I just click on the open, and you will see that it's going to take some time. Now, basically what happened, it came across some values which SPSS is not understanding, but if your data is in the form of a numbers, there'll be no problem. But if I do next, and finish, now you will see, oh, sorry, I think it's, let me share again because sharing has been stopped. I don't know why, but when I click next, now you see that that Excel sheet data has come here in the SPSS. So by default, because the values which were there in the first row, SPSS thought that these are the variable names. And I think SPSS correctly interpreted those. So you have title, publisher, field of research, rating, ISSN, ISS online, and website. And here you have the data view, because this was written in the form of a text, ratings, ISSN, and things like that. So the idea is like, this is how you can import data from Excel to SPSS.
Doctor, you said before that, sorry to interrupt, You said before that the program understands number, right?
Yeah. Yeah.
So when we, for example, when we have like, for example, gender and female, female, male, and whatever else, is it not easier maybe to write everything in numbers like female 1, male 2,
Yes. Yes.
transgender 3, for example, or even, like just prepare the worksheet
Yeah.
to be just numerical maybe in order to avoid.
That's, for instance, yeah, that's perfectly fine. Now, the statistical analysis which you're going to run here only understand numbers, but the Spss can take the alphanumeric input. For example, here you can see on your screen, these all are alphabets, right? Journal names. You can see here, title.
Yes.
So, but I can't do any statistical analysis on this because this is just a text. Now, for example, as you yourself mentioned, for example, if you have a gender like male, female, you have to code these. For example, you think 1 is male and 2 is female, or 0 is male or 2. The way we coded, the grades, you remember we coded A, B, C, D into 1, 2, 3, 4.
Yes, absolutely. So my idea was to prepare the spreadsheet in advance rather than doing it within the program.
Yes.
I don't know if it makes sense.
Yeah, it makes sense. Yeah, in advance, if you do that, that's perfectly fine. Now, for example, if you look here, basically this is an Excel sheet which tells us the rankings of the business field journals. Now, for example, if you look here at the rating, this rating is the type is string, which means it's like alphabets A, B, C, D. Now I have these discrete categories. I have like A star, A, B, C. I can convert them into numbers. For example, if I go back here to the variable view, I can find here the rating. If I go to the rating, from this type, I change from string to numeric, okay? And then I come here from this nominal, I change it to scale. And then I come to the values, the way we did there. Now, if I click on the values, we have the value of A star, for instance, here. A star, sorry. Value is 5. A star is 5. And if my label is A, value would be 4. Label is B, value would be 3. If it's C, the value is 2. And maybe I don't say that there is any, but if there's a D, the value would be 1. I add it, I click OK. If I go back to my data view, I think so. I think I did something wrong. You go to the variable view, it's scale, it's numeric, DCBA star, okay. Click on the save. I think I did something wrong, but the idea is like the way we, did with the grades, we could have done it here. Okay, if I just remove them, remove. Okay, and if we go back here, nothing is appearing. Change it back to string. And yeah, save. I don't know, I think something went wrong.
I think you need to recode if you go to data, maybe you should recode it first.
Maybe record into a new value. Yeah, you're right. Okay, I'll look into this. So I think we are already 7 minutes. We are exceeded by 7 minutes. So, okay, so that's it. Now for you, there is an assignment which you have to practice at your home. If you go to this, the folder, which link the link which I shared with you, you can see this assignment case number 1. There's a folder like this. Now in this folder, you have 3 files. The first one is case 1 sleep study. That is a assignment questions. And then you have the survey, which is sleep code book. And then you have a data set sleep 3 ED. Now you have to play with this data set. If you open, the Word file, it tells you that what you are supposed to do in your assignment. Let me share it with you so that. Yeah, I'm just gonna. Sorry, I thought that. Okay, so can you now see this case 1 sleep study new?
Yes.
Yes.
Okay, so for example, the data file sleep3ed.sav is condensed form from a study conducted to explore the prevalence and impact of sleep problems in various aspects of people's lives. Staff from a university in Melbourne, Australia were invited to complete a questionnaire containing questions about their sleep behavior. The file sleep_codebook.pdf contains complete questionnaire and related coding scheme, which is used in the SPSS. The file, sleep3d.sav. The sample file, the final sample consists of 271 respondents. You have to perform this analysis. Now, okay, so the first thing, because we have not done, we didn't get much time to talk about the missing values, so this we'll do tomorrow. So what you can do, you just look at the type of variables, okay, see what type of variables they are, and then you have to find a correlation and standard deviation and mean of these variables. So you have to do question number 3, okay? You have to do question number 3, which is you will find the correlation between these variables: weight, height, health rate, fit rate, weight rate, quals LP, impact 1, impact 2. And so, and you will also, you know what is meant by central tendency? Central tendency is the mean. So you have to assess the mean value. You have to also assess the dispersion. Dispersion is standard deviation, and shape of the distribution. This you will not do. This we will do tomorrow, okay? Because I have not told you that how to do it. So you will only look at the correlation between these 8 variables, their means and standard deviations. 3 things. Okay? Rest of the things.
Sorry, can I just mention that I don't have the SPSS? Can we email the advisor, or
I think
how
you
we
can.
get it?
Yeah, you can download the demo version from the IB. I think some Latifa, she is sharing the link.
Okay, I got it. Thank you.
Any other question? Okay, take care. Have a nice evening. I'll see you tomorrow, inshallah. Bye-bye.
Yes, sir. I have question.